Good morning students. Students, in today's video lecture we would solve the numerical problem which is related to chapter error in measurement. You are seeing in the blackboard which we are going to solve here. In an experiment, the following observation were recorded. Okay, L equal to 2.890 meter and M equal to mass 3.00 kg. L is equal to 0.087 centimeter up to 3 place in decimal, and diameter D was recorded as 0.041, 3 place of decimal up to. Taking G equal to 9.81 and using the formula we have given y equal to mgl pi r square l. Find the maximum permissible error in y. We have to find the maximum permissible error in y. So let's start. Students, you are seeing here that the value of L is measured up to 3 places of decimal. It means this is the sure digit, this is the sure, and the last one, this one is doubtful digit. The digit which is the last in decimal place, this is the doubtful digit. As we measured in the meter scale, when we measured in the meter scale, suppose 2.3, so 2 is sure digit, the doubtful digit is 3, 3 is the doubtful digit. This is the last digit. It means meter scale is able to measure correctly up to this value sure, but this is the doubt. So error could be at this place, error could be at this place, because the answer would be in between either 2 and 3 or 3 and 4, which we can say the answer is 2 and 3 if it is near about near to 3. Suppose this is 2.1, 2.2, 2.3, 2.4 and so on, 2.9 and then 3. If the answer is in between 2.9 and 3, we can say it is, we could take 3. In the same way, if the answer is between 3 and 3.1, 1, 2, 3 and so on up to 10. 10 divisions in between 3 and 4, 10 division in between 2 and 3. And if the value is lying between 9 division and the 10 division which is 3, then we can say either 9, 2.9 or 2.3. In the same way, if it is lying between 3 and 3.1, first division, so we can say it is either 3.1 or 3. So it means the error is in this last one digit in the decimal place. In the same way, here the error in this digit, error in this digit and error in this digit, and here the error is. So what is the amount of error for L? So the delta L, if the measured by instrument, so the delta L, mean absolute error for measuring the length could be 0.001 meter. In the same way, when we measure by this meter scale, then the error would be 0.1, because it is a sure digit. Maximum error would be 0.1 difference. Okay, here you can say this and this. This is 2.1 and this is 2.2. So the maximum error is what? 0.1. If it is lying between any two divisions, then either we can take 2.1 or 2.2. So the maximum error is what? It is the 0.1. I think you got my point here. So in the same way, the error in this length measurement by the instrument is 0.001 meter maximum error. For M, it would be delta M equal to 0.01 kg. For L, small l, delta L equal to 0.001 centimeter. For D, delta D is equal to 0.001 centimeter. And what about small g? It is not the measured value you are seeing here. It is a taking g, not measured value. It is not recorded value. It is a constant and it is 9.81. So there is no error in this term because it is not the measured value by an instrument. So we would not consider error in g. Okay. Now the formula for y is mgl pi. R is radius, but we have measured D, diameter. Then we would convert this R in terms of D. So what is the relation by radius and diameter? Radius is equal to half of the dia, r equal to d by 2. Just put here d by 2, so it would be d square upon 4. Capital. Okay. Now error in this delta y upon y into 100, percentage error concept by the combinations of error concept. The error in m, delta m by m into 100 plus, it would not consider for error measurement, so left it, delta L upon L into 100 plus this term, constant, these are constant, there is no error. In this term, this exponent is in multiplication and error in D is delta D upon D, it would be in plus, and this term again would be in plus delta L upon L into 100. यहाँ पर भी 100 है आपका into 100. So this is the equation which we have right here. Delta y upon y into 100. It means error in y is percentage error in y, percentage error in mass, percentage error in this quantity, plus percentage error in dia, percentage error in L. Just put the values and solve this. We got the answer finally. So we are going to put all these values. Delta y by y into 100 equal to delta m. Delta m. Delta m was what? 0.01. Delta m was 0.01 kg. So delta m is 0.01 upon m 3.00 into 100 plus delta L, capital L, this one is 0.001 upon 2.890 into 100 plus 2 delta D, delta D is into 0.001 upon D 0.041 into 100 plus delta L upon N. What is delta L? Delta L is 0.001 upon 0.087 into 100. 0.001 upon 0.087 into 100. So we have to solve this. Remove the decimal, all the decimals, and solve it. So the first value is 100 upon 300, which is 1 by 3 in percent. यहाँ पर cancel 0 to 0 plus it would be 10 by 289% plus 2 into 100, 200 upon 41% plus here 100 upon 87%. Just solve and add. 1 by 3. 1 by 3 is 0.33% plus 10 upon 289. 289. This is 10.0. Again smaller 0. 0. 3 times. 9 3 ja 27, 2 carry, 8 3 ja 24 and 2, 26 6 carry 2, 3 2 ja 6 6 and 2 8, 3 9 6 3 9 और 8 ये आपका 130.10 rupees. 4 times. So it would be 0.034%. Now 200 upon 41. 200 upon 41. 41, this is 200. Not 5 times, it would be 4 times. 4 1 ja 4, 16, 6, 3.0. Not 9 times, 8 times. 8 1 ja 8, 32. 2, 3.0. 4.87. So it would be 4.87%. Plus 100 by 87. What is the 100 by 87? 100 by 87, 57, and this is 100. 1 time 87, 391.0. Not 2 times. This is again 1 times. So it would be 87. 3, this is 2, 4, 0, 4, 1.14%. 1.14%. Now add all these quantities. Point 33, 0.034, 4.87, 4.87, and 1.14. 1.14. This is 4, 7, 1, 3, 6%. Answer is 6.374%. So the answer is 6.374%. Yeah, you can say it is 6.37% up to 2 decimal place. 6.37% up to 2 decimal place. So I think you got my concept here. Now the second problem of today's lecture. The second problem is this. Volume of a sphere is 1.76 meter cube. What would be the volume of such 25 spheres in view of significant figures? So we have to find the volume of 25 spheres. Actually this is a very easy problem, but when we consider the significant figures, then it would be some little bit different, little bit difficult. So the volume of 25 spheres is equal to what? 25 multiplied by volume of 1 sphere. And as we know that this quantity is related to measurement. This 25 is not related to measurement, it is just a number. And as I told you in the previous videos, for numbers, number of significant digit for the number, simple numbers, is constant. This is a fixed value, this is non-measured value, this is a constant value, fixed value, it is infinite. And this is volume of the one sphere which have 3 significant digits. So simply when we use the concept of multiplication, then the answer would be infinite significant digit and the 3 significant digits. In both these two, which have the minimum significant digit? This one has the minimum significant digit. So the answer would be contain only 3 significant digit, which is in this. So the 25 into 1.76. So just solve this value. 25 6 are 150, 0, 5, 1. 25 7 are 175 and 15, 190, 0, 19, 25 are 25 and 19, 44. So this is 44 and after. This is 44.00 meter cube. We have just multiplied. Now we would take the concept of significant figures as I have told you again, I am repeating, this is fixed value, this is not their measured value, this is constant number, it has infinite significant digits, and the volume of one sphere which have measured value related to measurement is related to this value here, and which have three significant figures, and this is the multiplication. For multiplication of two quantities, the significant digit in the answer is the minimum in both. It contains the significant digit for those which have minimum significant digit being multiplied numbers. Okay, so here infinite and here 3, so the minimum significant digit is 3. That's why in our answer the minimum significant digit must be retained. This is 3, so the answer would be 1 second significant digit, and this one is third. So 1 0 would be eliminate here, and this is significant digit, as we know that after decimal, if there is a before decimal, if there is a non-zero digit, and after that if there is a 0, it would be significant. So the answer would be 44.0 meter cube.